Hello, everyone. Thank you very much for joining CGCN's, or the Canadian Grapevine Certification Network's first webinar of 2025. We were on a little bit of a webinar hiatus for the past year, but we are back and ready to tackle 2025 by disseminating information to our audience. So starting off with today's webinar, we are going to focus on recovery from climate-related events, which happens to be a very relevant topic given the last few years in British Columbia, Ontario, and Nova Scotia, and actually very timely for Ontario, or at least Niagara, where I'm based, because we are living in the middle of a polar vortex right now. So I just want to note that today's webinar is being recorded and it will be posted on our website afterwards if you wish to review it again or share it with any of your colleagues. My name is Darian Temporal. I'm the Executive Director for CGCN, and I'm going to serve as your moderator for today's session. And we are joined by a pair of fantastic guest speakers. We'll have Dr. Gregory Jones from Abacela Winery in Southern Okanagan and Dr. Lizzie Wolkovich from the University of British Columbia. So to begin today's webinar, I'm going to first give a very brief overview of CGCN as an organization for those of you who may be unfamiliar if this is one of your first webinars that you're joining for us. And for others, it'll be a little bit of a refresher on what we do. And then Dr. Jones will start by addressing general climate questions and available variety options. And then Dr. Wolkovich will discuss local and general variety information in greater detail, including the intersection of climate and variety suitability. And then finally, we'll end our session here today with a question and answer period once all the presentations have completed. So please, throughout the presentations, please feel free to type in your questions on the Q&A section at the bottom of your screen, and then we will address them after the presentations have concluded. So without further ado, I'll get into my portion of the presentation here today. So CGCN is a Canada-wide not-for-profit incorporated in 2017 and is comprised of membership from 4 grape growing associations in Canada. This is being the BC Wine Grape Council, Grape Growers of Ontario, Council des Vignes de Quebec, and the Grape Growers Association of Nova Scotia. And each member association elects up to 2 individuals to sit on our board of directors. And so the CGCN board has maintained a mandate that is twofold. So first is to advance the Canadian grape and wine industry by ensuring a sustainable domestic supply of certified clean propagated grapevine material. This is both rootstock and scion material. And we aim to achieve this through our 2 certifications and 1 verification program, which I'll discuss in a little bit more detail in the next few slides. And then secondly, we support and promote grape and wine research efforts across the country and are currently administering the National Grape and Wine Science Cluster through Agriculture and Agri-Food Canada's, or AAFC's, Agri-Science program. We're currently in year 2 of 5 of that initiative. So firstly, I'll go into our Clean Plant Network side of things. So we have 3 programs, as I mentioned. Our highest tier program is our Certified Plus program. This involves material being held in CGCN's G1 repository, which we now have 2 locations for. One is at the CFIA Centre for Plant Health in BC, and the other one we have here in Niagara at Brock University at the Cool Climate Enology and Viticulture Institute. So material in this repository is tested for over 25 viruses and other pathogens of concern. We annually add new material to our repository to ensure that our repository is addressing the needs and wants of the industry. So if anyone here today would like to make recommendations to CGCN on what you want to see available clean, please let us know with the contact information at the end of my portion of the slides. But just note that if you make this recommendation and the board approves adding that to the repository, it typically takes 2 to 3 years before those vines are available to order. So within this program, we work with nurseries from the G1A level all the way up to G4, which is the G4 you'd be a grower will be purchasing those, and that material will be classified as Certified Plus. Now, our second tier, or our middle tier program, is called our certified option. So this program allows participating nurseries to propagate material from already existing vineyard blocks at the G3 level. And this has undergone high throughput sequencing testing, which is also tested for the 25 viruses and other pathogens of concern. So it's not as rigorous as the Certified Plus option, but it still allows nurseries to provide certified grapevines to buyers in a timely manner, and it does not compromise on the thorough virus testing. And this is denoted and classified as certified material. Material here would be available in a year or less. And our last program is our verification protocol, or our lowest tier. This was put in place initially to provide a temporary option for virus-tested grapevines until sufficient stock of certified material has been propagated under our 2 certification programs. So we are testing for leaf roll 1, leaf roll 3, red blotch, and tomato ring spot virus in this program. And material produced according to these protocols is denoted as verified, but as listed on that last bullet point there, we are phasing this program out by 2028, March 31st, 2028, and the vines that are produced under this program will be eligible to be sold until July 31st, 2029. So now I'll briefly address the research portion of our mandate, and we're currently administering the Grape and Wine Science Cluster under AAFC's Sustainable Canadian Agricultural Partnership. So this cluster contains 15 research activities being conducted at government research centers, universities, and/or private research facilities across the country. The research in the cluster is organized into one of 3 themes, or priority areas is what we call them. So being climate change and the environment, economic growth and development, and sector resilience and societal challenges. And we're currently in year 2 of the 5-year cluster. So year 1 summaries are posted on our website if you'd like to learn about each of the activities in more detail. So you can find that by going to our website, hovering over the research tab at the top and clicking cluster updates and events. And the last thing that I want to highlight before we get into our speaker presentations, and fitting for the topic of today's webinar, I want to highlight this resource that CGCN released in December. It's a Clean Vines Frequently Asked Questions form. We developed this in collaboration with the British Columbia Wine Grape Council, Grape Growers of Ontario, Council de Vin de Quebec, and the Grape Growers Association of Nova Scotia, so our 4-member organizations. And we made this to help educate members of the industry, clarify misconceptions, and empower growers to make informed and educated decisions when purchasing or planting clean material. So if you're interested in accessing that form, you can go to our website under the resources and updates heading. I'll show it again here, and clicking latest news and updates. And just in general, any resources or tools or best management practices will be uploaded to CGCN's website here. So thank you very much for your time. If you want to ask any questions or you have any recommendations for our G1 repository, Ethan and myself are more than happy to answer any questions and take requests. But without further ado, I will stop sharing my screen here and I will introduce our first speaker for today. So we have Dr. Gregory Jones is the CEO of Abacela Winery, his family business in the Umpqua Valley of Oregon. He's spent the last 25 years as a climatologist who specializes in the study of climate structure and suitability for viticulture and how climate variability and change influence grapevine growth, wine production, and quality. He's the author of numerous book chapters, including being a contributing author of the 2008 Nobel Peace Prize winning Intergovernmental Panel on Climate Change report, and other reports and articles on wine economics, grapevine phenology, site assessment methods for viticulture, climatological assessments of viticultural potential, and climate change. So without further ado, Dr. Jones, please take it away.
Well, thank you very much. I appreciate it. Let me get my screen set up here. Can you see the opening screen?
Yes, we can.
Yes. Okay, thank you very much. Well, I appreciate being here with everybody today and those that potentially will watch this later. This has been a year in coming, and very happy to be able to share some information with you. I am going to talk about what I think is really important that many of you probably have some feeling for, but kind of the nature of how we've been experiencing our changing climate, especially in extremes. I put this image right here that you see as the current departures from normal. This was late last night over North America. And I put this up to show you that there are currently places in parts of the US that are roughly 10 to 20 degrees Celsius below average, while there are places in Alaska, northern Canada, and Greenland that are up to 10 to 20 degrees Celsius above average. This is a definite component of kind of what our climate has been up to over at least the past 50 years in a much more pronounced way than we have historically. So I'm going to talk a little bit more about this, but I just wanted to put that into perspective as we kind of move into the presentation. The other thing is I will be producing a PDF of this, so you'll be able to have it to go back to and look at it as you wish. So what I'm going to do is I'm going to talk real quickly about change factors in wine, and then get into really just the broad categories of what do we know and what don't we know but really need to know, and then try to give some conclusions. I'm not going to necessarily recommend anything very specific other than the awareness of kind of how these things are changing, how we need to address them, and what we might be able to do as we move forward in the future. So change factors in from this perspective is that climate change is a really big issue, of course, but it's just one of many factors that put pressure on the wine sector. And these include national to international economics, clearly, declining demand as we know that's happening today, and also changing demographics, which is a part of that. Challenges from other beverages, of course, new markets, new consumers, new styles, and having to address those. Changes in the tastes of wine writers and raters, whether or not they're as important as they ever were. Production and movement of bulk wine, which is just, this completely blows me away. If you don't know what's happening in bulk wine, you really should, because I think this is a large part of some of our issues. And then demand for greater sustainability. Now, I know this has nothing to do with necessarily what we're talking about today, but I put this in perspective because whether or not you're operating as a new vineyard, a new winery production facility, or recovering from a catastrophic set of events like many are in Canada, this is the background behind what we're dealing with within this industry. So it's not as simple as deciding what the best variety is. It's really figuring out how does it fit within this entire metric of issues that we have surrounding the wine sector. So with that, I want to go into kind of what we know. And from that, I can tell you that it's pretty clear the climate is unstable. Here we are in January of 25. All of the data has come out from all of the major agencies around the world. 2024 was the warmest year on record. And you can see the basic framework is that we are in a rapidly warming environment. As such, the climate is fairly unstable, and I'm going to talk about that a little bit more again relative to climate extremes here in a little bit. We also know that terroir is important. And this diagram here is just kind of is a visual to say that, we have many, many things that we look at relative to understanding what to grow where and how that results in a marketable product. But I can tell you right here and now that the most important issue is making the right decision on the variety that fits within the climatic environment of that location that can be grown within those soils and produce a wine style that is effective and economically viable overall. If you don't go about matching variety to climate, all of this becomes a different issue. I can't tell you the number of times I've traveled all over the world and people are planting Cabernet Sauvignon everywhere. It's not that I want to poo-poo Cabernet Sauvignon, but the framework is that it's not suitable everywhere, just like many varieties aren't. And so we just need to be very conscious of the fact that you have to make this decision correctly, whether you're planting a new vineyard or recovering from these cold events that you've experienced in Canada. We also know that Vitis vinifera and many Vitis, even hybrid species, have a basic framework behind which they function. And it's typically a 7-month growing season. Too long doesn't work, too short it doesn't work. And the temperatures need to be roughly about between 12 and 22 degrees Celsius during the growing season. We know that within the bounds, individual varieties have their own temperature niches, maybe 1.5 to 3.5 degrees Celsius, depending on the variety, for producing economically viable crops and making quality products. We also know, and as we're talking about here today, that Vitis species do not tolerate extremes very well, some better than others, whether it be on the cold side or the hot side of things. And we'll talk a little bit more about some of those here in just a minute. One of the big questions I think that we need to ask ourselves, do varieties have some genetic adaptive capabilities within their framework? Likely, but is that something we can utilize? It's a big question, I think. And then how much will external measures that we do as managers of vineyards adapt varieties to current and future climates? Because I think we have a big potential to do some of that. It's just that figuring out what the best adaptation strategies are really critical. We also know that climates have changed in wine regions worldwide. That's absolutely clear. I started this work back in the late 80s, early 90s. People were mostly in denial back then, but all the early models that I dealt with predicted pretty close to what we're experiencing today. As a matter of fact, we even a little bit even under predicted it. And so this is really much more evident today than it's ever been. Temperatures are changing a little bit more than precipitation, but it doesn't mean that precipitation framework hasn't altered as well. We know that there are changes and extremes occurring in many aspects of the climate system, whether it be temperature events, precipitation events, or other extreme climate events. Just a real quick picture looking at some temperature trends and some data. We did this project a few years ago, and I just wanted to give a framework from it. We looked at 25 prominent wine regions around the world, and all of them warmed. If we averaged across the regions, it was 1.4 degrees Celsius. Emerging cool climate zones in both hemispheres were warming quite a bit as well, but significantly more in the northern hemisphere. We'll talk about that a little bit more in a minute. What else do we know? We know that grapevine phenology has shifted roughly 4 to 8 degrees per 1 degree Celsius, depending on variety and location. And I think Lizzie will talk a little bit more about this in her talk, but this is pretty prominent. I have data from all over the world that shows that this is a basic framework. And that means that grapevines are telling us that they're dealing with a different climate. We also know that growth intervals have contracted for many varieties in many regions, meaning the length of time between the major phases have contracted slightly. We also know that there are typically earlier harvests in a warmer part of the year, or we're having issues with hang time where we're having to hang the crop much longer because the fact that we're disconnected in terms of how the ripening is occurring. We know that harvest compression has occurred across varieties. If you've grown multiple varieties in a vineyard, you've got a wide diversity. These varieties are harvesting more together within their harvest calendar than they did in the past. We also know that the ripeness clocks have been quite a bit out of sync. You can look at data from many places around the world, and it shows the sugar accumulation, acid respiration, phenolic development, and flavor development are not as in sync as they used to be because of climate-related issues. We also know that that produces changes in wine styles. That's pretty clear. There's some market-driven issues there as well, but definitely climate is driving it. You can't do it without climate changing. I'm only going to show one of these pictures. I think Lizzie will have some more, but this is just a look at Grenache in the Rhone Valley, looking at how phenological changes have occurred over time. Every year has been getting earlier and earlier. And then if you look at some of the fruit characteristics, whether it's acidity declining, potential alcohol going up, meaning sugars going up, or berry weights declining, these are all effects of climate that have happened over time. Now, I'm just showing one. I've got dozens of similar kinds of examples from other places around the world as well. So going back to what do we know? Well, I'm talking about West Coast. I know that Canada and the U.S. span East and West Coast, but I want to get to this West Coast issue because mid-latitude environments, mid to even high latitude environments on West Coast have same challenges that come with winter cold and wet characteristics to summer hot and dry cycles. As such, these regions all have strong climate variability mechanisms. These regions are all prone to long-term droughts on top of seasonal drying. And then these regions are all prone to extreme winter temperatures and precipitation events. So to kind of take that to the next place, what I'd like to do is talk about what are some of these climate variability mechanisms? What do we know about them? And then how can we use them to better understand what's happening within the wine regions that we work in? And I'm focusing here on British Columbia, but you can do the same thing virtually anywhere. You can identify what those factors are. In British Columbia, it really is three major ones. The relationship to, of course, the Arctic, but then also the Pacific Decadal Oscillation. I don't know how many here know about this, but I think this is a very prominent component of our seasonal variability. And then, of course, El Nino Southern Oscillation. But one that isn't talked about a lot is changes in Gulf moisture and how that can be brought up into the plains and then up against the Canadian Rockies and how that might influence things. But I'm going to talk about a few of these here, give you a sense of what's happening. First of all, I think one of the biggest things that we've been seeing in number one is the tropics to poles temperature gradient has been declining. This is basically because the northern hemisphere, the Arctic region, has been warming much faster than the equator. And these two diagrams only go through about 2012, but I can tell you that the data that I've seen is basically showing that this trend is continuing. The reason that this is important is that it changes the dynamics of mid-latitude to high latitude seasonal to annual climate variability. If you look at this, one of the big frameworks behind this, and I know was mentioned earlier when we got started, that talking about the polar vortex, and this is just a diagram of the basic jet stream structure in the mid latitudes in a kind of a normal framework. We know that there's been some major changes in this over time, and it's basically called Arctic amplification, where the Arctic region is warmed 4 times the rate of the rest of the planet. This has basically caused the jet stream to slow down slightly, have more amplified north-south waves like the one that's down in the Gulf Coast of the US today. We have greater swings in season and climate from year to year, season to season, month to month. Now we know that there's some indication of similar activity going on in the southern hemisphere, but because of landmass differences, it's not quite as evident as it is in the northern hemisphere. I also want you to kind of show this. I know this is some old data here from 2014, but the framework I wanted to show here is that even over an annual cycle, we can see some of these kind of patterns set up in terms of their structure. 2014, the Western North America was warm, Eastern North America was cooler, then far Eastern North America and the Atlantic was warm, and then the Greenland, Iceland region was cold, and then Europe was warm, so on and so forth. What happens is that these changes in dynamics between the Arctic and the tropics really influences what we are seeing today. Short and long-term omega blocking in the atmosphere to produce these kind of patterns, or in British Columbia and parts of the Western United States, what is called Rex blocking, where it's tilted and brings cold events into our region, but also can produce heat events and even the Santa Ana winds that developed over the past 3 weeks or so in California. So anyway, you can see that there's a lot of drivers there that produce quite a few things that we've been experiencing. We can also talk about INSO and climate variability. Number one, I just want to say that when we look at this framework, we're looking at the tropical Pacific and how that varies from a heat standpoint, whether the temperatures at the surface are colder than normal, La Nina, or warmer than normal, El Nino. The swings back and forth between these two states of the tropical Pacific are the largest source of predictable interannual variability in the global temperature record. It helps us understand what we can potentially expect within a winter or a period of time in different places around the world. And of course, this is the North American influence that I think many are probably familiar with. El Nino winters tend to be a little warmer across the northern tier of the US and into Canada. Whereas La Nina winters, like we're seeing this winter, we're tending to get a much wetter and colder period into the northern part of the country, where California, across the southern tier states, is tending drier, although we are, of course, in a cold polar vortex event right now. The next one to speak about is the Pacific Decadal Oscillation. I pay a lot of attention to this, and I have for many, many years, because the framework behind this, I think, is as important, if not more, than El Nino Southern Oscillation in the United States. The positive phase just shows a very cold North Pacific with some warmer waters along the coast of Alaska, British Columbia, and the Western US. The negative phase is essentially opposite of that, and it shows a very warm water in the central to western Pacific. In the framework behind this, what we see is that when we're in a positive phase, we tend to have much warmer conditions in through Western North America. Where in the negative phase, we tend to have much colder conditions into Western North America. We have pretty good data about this oscillation. We know it tends to act more on a decadal kind of framework. And this goes from 1854 to 2024. And you can see that the positive phase or the warm periods are in red and the negative phases are in blue. It's not perfectly decadal, but it's more decadal than El Nino Southern Oscillation is. And it has a tendency to be pretty prominent in what I see in our winters here. And I know within Western North America winters, we are currently in a negative phase or a cold PDO at this current point. Now, if you look at some of this and you think about how does this drive what we're seeing, it's highly correlated with temperatures and moisture variability, but especially temperature in the winter and spring. When it's in this positive phase here, we have a tendency to have warmer temperatures and fewer winter freeze events and lower spring frost frequency all throughout the Western United States. When you look at the negative events, they're linked to much colder and wetter winters, the greater potential for winter extremes and spring frost events all throughout the Western United States. However, this is really important. A lot of people don't talk about this. The phase of El Nino Southern Oscillation is really important. You can look at one, the Pacific Decadal Oscillation being a longer term kind of phase framework, whereas ENSO is much a shorter phase. It operates within a shorter time frame. But when they line up, when both are cold or both are warm, the impacts are much greater. So you can really kind of dial this in and look at what does that mean for winter extreme cold events or spring frost events or moisture related issues as well. So I think this is a very important aspect of understanding that. Just real quick, I wanted to mention, we've been talking a little bit about the ocean, of course, with El Nino Southern Oscillation and the PDO. When we talk about the oceans just in general, this is some data going from 1854 to 2020. And the basic framework here is the oceans are warming too. And while the trend is a little lower than the trend of the air temperature, the bigger point here is that the ocean heat content with depth is gone up tremendously. This means that the ocean is storing heat in a way that we just don't have any observations that can tell us how it's going to function. So this whole biogeochemical cycling in the ocean is pretty important in terms of how we look at both current climates and future climates. And to put the two in perspective, this just shows the difference between the heat content between the oceans and the land atmosphere and ice heating. The oceans are just dwarf the magnitude in total heat content in joules since 1961, and this has continued to go up since this data here. So that takes us to a whole bunch of aspects of viticultural wine production and climate relations that we know relatively well. So then what do we need to know is, I think, the next biggest thing here. How will climate extremes change over time? Really an important issue, of course. How will drought characteristics and frequency change? How will cold extremes change? So we're going to talk about each one of these here, but I wanted to talk about some research that's come out just recently about what's called hydroclimate volatility. And I think this is really important for everyone, but this work that was done by Swain et al. Just recently came out, looked at very specific places. Of course, Pacific Southwest and North Central US is the closest area, of course, to Canada. But this is happening all over. And what it is that we're seeing very sudden, large, and or frequent transitions between very dry and very wet conditions. This is connected to essentially that a warmer atmosphere holds more moisture. So you have a higher water vapor pressure capacity, you have a higher potential evaporative demand in many places. So in some ways, dry regions are getting drier, but warm, wet regions that have seasonal wet cycles are seeing them more intense as well. This subseasonal to interannual whiplash is being called within this framework, have increased by 31 to 66% subseasonally and 8 to 31% annually. So we've got change going on in this framework. And the reason this is important is that it has a tendency to influence drought frameworks over North America that I think are really important, and especially the potential to kick North America into a mega drought. It's the sensitivity behind that. Small droughts over time can potentially drive ourselves into a mega drought framework. So again, this kind of potential of this hydroclimatic volatility is really important. One of the other things that happens, and this is just some data from a research paper a few years ago, that dry regions that get drier, whether it's seasonally or annually, will also likely see accelerated warming. There's a big concern for this in the driest parts of the United States and Canada, Europe, and Asia, Australia as well. So again, how these feedbacks happen over time will be really important to see where we end up in our future climate. So moving off into temperature extremes and trying to figure out kind of what's driving some of this when we don't know is number one, heat extremes globally have increased while cold extremes have decreased at a faster rate, meaning that heat extremes have gone up much more rapidly than cold extremes, while cold extremes are decreasing. Record warm extremes are now occurring somewhere between 15 and 25 times the rate of record cold extremes. A stable climate would be somewhere near 50-50. And I know you're saying, well, we had 2 winters in a row of extreme cold in parts of Canada, of course, and British Columbia. But the issue is that these events haven't gone completely away. They're just, their frequency has changed quite a bit. And we do know that the magnitude of multiple successive events, so a heat wave of 5 days, 7 days, or a cold wave of 4, 5, 6, 7 days, a shift a little bit more in warmer events. Warmer events are getting longer duration, is the take home. We also know that a changing climate is impacting winter cold extremes in various ways that are somewhat a little bit uncertain of where and how this might play out over the long term. What we do know is this, that this diagram right here is winter temperature changes in the Northern Hemisphere over 1989 to 2016. Warming events during the winter over the Arctic is very clear from this diagram. Decreasing temperature variability also suggests that frequency and intensity of cold extremes have reduced relative to mean changes, meaning that warm events or cold events have warmed up more than the mean. But cold air outbreaks like the one we're seeing today in eastern Canada all the way down into the Gulf of Mexico are really becoming more likely because of these changes in atmospheric circulation. When we look at, this is some recent research out as well in Nature Communications, trying to decompose trends in cold events in North America. What we found is cold extremes have warmed 2.2 times more than winter mean temperatures, meaning that the coldest days, the 2% of the coldest days on record, have warmed much more than the average temperature during the winter. And we also know that this has warmed 3.2 times more than the global annual mean trend. The warmest days over North America fluctuate, with some regions warming slightly and others closer to average. This amplified warning is linked to decreasing variance and changes in something that's kind of interesting, the skewness of the distribution, where many years are becoming more similar, while there's still extreme years that tend to have very cold events that are out on the tail of the distribution. Cold extremes in the future. We know that in the current climate, winter temperatures over North America up into the Arctic have the highest variance and are some of the most strongly negative skewed on Earth. What that means is that extreme deviations below the mean are expected to continue in the future, even as rising temperatures occur. With increasing mean temperatures, combined with changes in temperature variability, cold extremes over North America are likely to occur less frequently, but when they do, they will likely be less intense. And I put a however in here. I think there's something that even punching all the data that we know now will never really answer. And I wish I had a way to better understand this. If we live in an environment where we have cold events, whether they be winter freezes or spring frosts, much more frequently, then we as managers of a crop system have a tendency to be much more in tune to those type of events. But if they occur less frequently and we don't see them and we become very kind of unexpected when they do, then we don't have the ability to manage them culturally, and or maybe the plants don't have the ability to deal with them in terms of their hardiness framework. So big question that I think that we still don't know. So some more, what do we need to know? How will varieties perform in a climate that is more variable in some ways and less so in others? How will varieties perform at warmer temperatures over the long term? I would make an argument here real quickly that when we talk about both cold events and warm events, we know less at the higher limits of varieties than we do at cold limits. We're seeing losses in color at higher temperatures. How do we kind of get to that framework? We also need to know what these limits are so we can better assess what type of varieties can perform. And I think the heat stress side of it is going to be just as big, if not more so than the cold limits. It's just that there's going to be some places that will have more of one versus the other. Drought tolerance is, of course, a big issue across varieties and rootstocks. Disease pressure. This is something doesn't get talked about as much because there's limited modeling looking at this. But when we talk about disease pressure, whether it be a virus or a bacteria or fungal infections, how do they occur? Because in an atmosphere that's warming, we're going to have higher humidity, and that's absolutely clear. So how does disease pressure change, and then how do we manage that in the future? And then how will all of this influence terroir? Will everything we know about terroir of the past hundreds of years be the same, or will it be different? Big, big questions. I know that Lizzie is going to talk a little bit about this, but I need to bring this up. There's roughly 5,000 unique varieties grown worldwide in the wine grape environment. Even in the book Wine Grape, I worked with Jancis Robinson on this. She and Jose identified 1,368 commercially grown prime varieties, meaning more commonly grown. I also worked with Kim Anderson and Seguin Naglin on the book that they've done on varieties worldwide. And I produced a climate structure framework in there for 813 different varieties, where they're grown in the world. So you can see kind of what that climate framework is. But the problem I think we've come to is this. The concentration of varieties worldwide has increased, where we're now sitting at 50% of the world's plantings are done with 16 varieties. And if you look at New World wine regions, 7 varieties make up 50% of the plantings. I think this is part of our challenge right here. We have so many genetic options that we can potentially use, yet we've honed in on this grouping of varieties that really has created a consumer producer conundrum as we look at the future. We plant things because that's what the consumer knows how to pronounce. They see it commonly in the grocery store or the wine shop, and therefore they buy it. So we continually try to grow those. But somewhere along the way, this needs to change because we have options to deal with cold extremes. We have options to deal with hot extremes. We have options to deal with drought tolerance. We just need to be open to how to manage these varieties and how to make them commercially viable. So with my conclusions from this, and real quickly, I think it's pretty clear that the planet is warmer than than any time in our recorded history. And it's pretty clear continued warming is highly likely. I'm only showing this because I wanted to get a perspective for 2025 where we're sitting. This is data from Berkeley Earth, and I've been working with them and watching these forecasts for many years. This just came out at the beginning of January, already forecasting the likely range for temperature in 2025. We have roughly a 90% chance of 2025 ending up in the first, second, or third warmest year on record. And it's because of persistence in the climate system. It's just not going to change like that. So we definitely know this framework is out there. We also know that continued warming is likely as well in the future. And when this was actually put together by Berkeley Earth, there was just a linear framework that was put toward the end of this climate distribution here. And you could see that by 2033, the linear framework was projecting that we'd be above 1.5. Well, even this right here is now pretty much too low. So we've got some changes to better understand what that looks like in the future. Lastly, we all grow grapes. I grow grapes. I've been around this industry for a long time. Agriculture is both part of the problem and part of the solution. We just need to understand this as we're, whether we're planting new vineyards or replanting a vineyard after a catastrophic event like British Columbia experienced. Mitigation is absolutely necessary, but adaptive potential is large. Yeah, and I think we just need to look at both of these at the same time, trying to figure out kind of what is the best adaptive framework that we have while we're mitigating our agricultural inputs to the climate system. We absolutely need to use the wealth of crop diversity. This is just essential. And I don't have the answer here whatsoever, but I just know that somehow, some way, we need to be able to plant different varieties that give us different potential within a given environment and lower our overall risk. It's just really essential. So building resiliency in each of our agricultural systems is absolutely a must. And really, there's no silver bullet. We're going to have to do a portfolio of things as we look to the future. And I hope that this presentation is giving you some sense of kind of where I think the climate framework is relative to the wine sector, and especially through our region here in North America. And I look forward to Lizzie's presentation and hopefully some good questions here in the next hour or so. Thank you very much.
Thank you very much, Greg, for your presentation. I'm just alarmed by the fact that we are already much warmer than what the predictions were years ago. That's just highly concerning. And then I had some other thoughts within your presentation. Something good to know was that within the Pacific decadal oscillation cycle or metrics, whatever that how you use that term, we're in a negative phase. So it's good for growers to know that we can anticipate, at least according to the data, that it'll be colder and wetter spring. So anticipate maybe some spring frost events. And then another item that I just wanted to also highlight and connect back to CGCN, you highlighted opportunities for further research into heat stress limits, and that is definitely something that we didn't start. We only started looking into, I believe, in the last cluster, and we're continuing that work again here. And obviously opportunities to explore new varieties in different regions in Canada. We need to figure out how we can create more unique characteristics within our country, within our specific growing regions, and then market that to consumers. So it doesn't just stop in the vineyard. We have to be able to sell that to the customers. So thank you very much. And if anybody has any questions, just a reminder, please put those into the Q&A box at the bottom of your screen there, and we'll address all questions at the end of Lizzie's presentation. So I will now introduce Lizzie. We have Dr. Lizzie Wolkovich, who is an associate professor in forest and conservation sciences and Canada Research Chair at the University of British Columbia. She runs the Temporal Ecology Lab, which focuses on understanding how climate change shapes plants and plant communities with a focus on shifts in the timing of seasonal development. She's particularly interested in how climate change will affect different wine grape varieties and how shifting varieties may help growers develop climate-smart and resilient vineyards with warming. Her research benefits from an interdisciplinary team of collaborators from agriculture, biodiversity science, climatology, evolution, and viticulture, as well as from shared long-term wine grape data sets from across North America and Europe. So, without further ado, take it away, Lizzie.
Many thanks to the CGCN for inviting me. I'm assuming you guys can all see my screen. If not, shout. And many thanks to Greg, Dr. Jones, for such a wonderful presentation. I am struck by how similar many of the themes you'll see in mine are, and I can hopefully move through them a little bit more quickly so we can get to questions. I know Greg vaguely, but I would actually just say it is, if you spend a lot of time looking at the data, I think how similar his presentation is to mine suggests that researchers arrive at very similar conclusions. So even though there's uncertainty in the climate system, and there's always uncertainty in growing a crop and dealing with weather year to year, there are really certain themes coming out of the research that people are doing in totally disparate areas, ending up with similar solutions. So with that, I thought I'd start very quickly with some climate change images of what is shifting in different regions. So the terroir, if you will, what is the climate space of the terroir and how has it changed over time? And I'm going to pick a bunch of regions that actually are very particular to the varieties that they tend to plant. So for example, in this first figure, I'm looking at the two-dimensional climate space of Napa and Bordeaux, which tend to grow similar like Cabernet Merlot style varieties of wine. The total growing degree days, I believe this is above 10 degrees C, but I should double check, is on the horizontal axis, and the maximum temperature in Celsius is on the vertical axis. So the pink is showing you sort of for Napa, what is the range of climates they get in GDD and maximum temperature together. So higher GDD years, you see higher maximum temperatures, for example, and then Bordeaux is overlaid. But these are actually the data for a period that was before substantial anthropogenic warming, so 1951 to 1979. And if we shift forward and look at the next 30 years, you'll see that both of these regions have warmed significantly. Bordeaux a little bit more than Napa, but moved into a much warmer climate space. And you can do this for any set of region or any region on Earth, really. I'm showing the United Kingdom here now in pink, and the Champagne growing region of France in blue. You can see the axes have shifted in the numbers. So we have far lower GDDs in these regions, and they don't tend to get as hot. But again, they've both warmed a lot. And in these metrics, you can see the United Kingdom has really moved into much of the climatic space of Champagne. And Champagne is now trying to deal with temperatures well into the high 30s, which is really very high for them as a growing region that hasn't really seen those temperatures before. And they're getting a lot warmer thermally across the growing season. One more, the Willamette and Burgundy, Pinot Noir style and other lighter style of wine grape varieties, sort of in between the two last regions in terms of GDD and maximum temperatures, but both warming as well. You can see Burgundy has really shifted into substantially higher thermal growing seasons in terms of GDD. And again, is also starting to see these temperatures in the high 30s as sort of regular maximum temperatures, whereas they would have been prepared to deal with mid-30s as a high before significant warming. This is the reality for climate change across most regions. And I picked GDD and maximum temperatures because in new analyses I've done, those are by far the biggest shifts that we're seeing across regions, which is interesting because in general, climate change on average is warming minimum temperatures more than maximum. But if you look at a lot of metrics that matter to how we choose to plant grapes and which ones we should plant, consistently across most regions, the biggest changes are happening in maximum temperatures and growing season thermal heat or growing degree days. We see that similarly, I would argue, in data I've looked at across the Okanagan and BC, for example. So these regions are warming, maximums are going up. And additionally, minimum temperatures are going up and the risk of freeze damage is going down. So this is a paper published about 2 years ago with Carl Bogdanoff, who some of you may know, myself and a postdoc in my lab, Faith Jones. And it is showing the freeze injury risk days. So using data from the Okanagan, fitting a model for how often we would predict freeze events, with each red line being a variety and the black line being the overall average. You can see there's a trend downward. If you were going back to the 1950s, you might have expected an average of 10 potential freeze days. And now we're well on our way to like 6 or 5. So they've decreased in half according to these data. As Greg mentioned, it doesn't mean they go away though. And so I wanted to look quickly at the data from the cold event that happened just last year, even though it feels somewhat like a lifetime ago to me. I can imagine how it feels to growers in the region. So these are the climate data coming from the Environment Canada data stations. So these are the observed climate data. I'm looking at minimum daily temperatures on the vertical axis in Celsius. And I've plotted out the temperature across this period. I showed 3 sites, Penticton, Summerlin, and Kelowna. You can see they're very similar and they go in the predicted order, with the northern site getting the most extreme cold temperatures. And what causes these freeze events to be so damaging has some uncertainty around it, but there's a lot we actually do understand about hardiness. And in the Okanagan in particular, there is a lot of good data that was being collected by the Summerland Research Development Center that has made it somewhat easier to rule out what didn't happen, I would argue. So I just want to walk through it so growers understand sort of my research understanding of what happened. It got incredibly cold, incredibly fast, as you can see in these data. So we're looking at temperatures in the low, 0 to 5 degree minimum. And then suddenly we have a low of 30. Across the sites, there were hardiness values taken just before the cold event. So we have some sense of how hardy the plants were. I think one question is always, with climate change, are plants, because plants acclimatize across the winter, they gain cold hardiness. They don't start with it in September. They are exposed to cold temperatures each winter, and each winter they slowly gain the ability to withstand colder and colder temperatures as long as they're exposed to those cold temperatures. So here I'm showing in this pink band the range of hardiness that was observed from buds across the region, I think just a few days or a week before the cold snap. Again, coming from the Summerland Ag Canada Research and Development Center. And they range from about negative like 19.5 to negative 26. And this is approaching maximum hardiness for most Vitis vinifera varieties. Things usually can get to like 23, 25 at the maximum, and it varies a little bit with variety. So these grapes were quite hardy, I would argue. If you look in parts of the Finger Lakes region, they rarely gain this much cold hardiness because they just don't see as cold temperatures. So whether there was warming before the event that made the plants less cold hardy, I would say it was not extremely cold right before the event. But based on the data that we have, it suggests the plants were extremely cold hardy. And it would have been hard for a lot of varieties to actually survive this sort of cold snap, especially because it was negative 30. So very few varieties, even some of the best hybrids, can not necessarily withstand negative 30. And just to show you the diversity of varieties in here, I'm showing the middle part. So 50% of varieties were about negative 23 to 24 degrees hardy. So that's quite hardy for vinifera. Marquette, this hybrid coming out of the University of Minnesota, was the most hardy of the data. There wasn't much data on it, but there was an observation of Marquette. It was about negative 26. Oops, sorry. And I should have put it in Pinot Gris was the least hardy if you looked at the data. And this comes again from Ag Canada, 50% lethal mortalities. But what I hope you can see is that the weather data goes far below this. So you would expect really total vine loss, especially given how long the cold event lasted as well. So biologically, we do understand what happened here. And it's not that our data suggests it shouldn't happen, it's just that it might happen less frequently. And I really appreciated Greg's point about we might find it more difficult to deal with as growers and researchers because we just don't see it as often, where it is something much more normal to have to deal with in the BC growing region. And to show you again this figure, it captures that yes, at the end of this period of data, there are fewer freeze events, but each dot actually shows you what we estimated for a different grid cell in the Okanagan for a different variety of hardiness. And you can see, there are some dots in the late 2000s, so in recent years, that are getting 20 days of freeze risk. So potentially 20 days we would predict injury depending on where you are in the region and also what variety you're growing. And this region, you can look at the paper, is really just the central Okanagan. It doesn't go very far north at all either. So there's huge variety by site and variety that we have to try to deal with. And so I'll talk hopefully just over the next 10 to 15 minutes about why variety matters and specifically the phenology of the varieties, as Greg already touched on, how it can help buffer wine growing regions. And then I'll just give you a little review of what a couple different places are doing, just two areas, but I can talk more about others. And I think you could ask Greg about how he's handling these sorts of challenges as well. I'd be intrigued to hear. I should say I am not a grower, so it is really refreshing to be able to refer people to Greg, who has all the expertise of trying to do this on site. Okay, why does variety phenology matter? So the main phenological stages that we think about when we think about wine grapes are bud burst in the spring, followed by flowering, followed by veraison, followed by the ripening or maturity phase. And each of these is something that you're already naturally selecting on when you pick a variety for your region, hopefully, because you have to pick a variety that is going to get from bud burst to ripening within your growing season. Maybe not fully ripe if you're doing a champagne style wine, but some amount of ripeness that you need. If you have frost spring events, you might want it to not bud burst too early, but you certainly do want it to have not too late that you can't get ripeness. So there's this real tension of having it fit the season, but not be too early for frosts. Flowering is obviously critical. You need to have things copacetic and nice enough that you get high yield. And then certainly there's been tons of research by Dr. Jones and others that really highlights that this phase of veraison to ripening, the climate within it is super critical to getting higher quality grapes and really nice flavor profiles from the grapes to make a great wine. And the general climate you want is sort of the end of season climate. So if you have berries that are ripening in the hot extremes of August, they're usually sugar rich and less complex and interesting. And so most people who are trying to adequately match their variety to their climate to produce a high quality wine are really interested in finding a variety that takes up most of the season so that the variety will ripen towards the end of the season. Obviously a delicate balance. You want it to ripen all the way, but you also want to find one that isn't ripening so soon that you're trying to harvest it when it's August and it hasn't had enough time to sort of slowly ripen and get the complexity and interesting flavor profiles we want for high quality berries to make high quality wines. So these are sort of the three basics, but I would argue that there's increasing research that shows, matching your variety to your climate is also going to be critical to how you experience as a vineyard and a grower climate extremes. So I think of these as like climate hazards, and I've shown two here, but just to walk you through how each phase really matters to matching your phenology of your variety to your climate. As I mentioned, bud burst clearly matters to frost risk, and this is something we've always known. If you have an area that tends to have a lot of late spring frosts, you might want to be considering varieties that bud burst a little later, so that you are coming out after the frost risk. But I think there's interesting increasing research on flowering, especially coming out of southern France, where the plants that are seeing the most damage during some of the big heat waves hitting Europe are the plants in the flowering stage. We don't usually think of flowering as being the least heat tolerant. It's actually a fairly heat tolerant phase according to models. But there's increasing evidence that the plants are not in a good position to deal with a heat extreme. And flowering is really only heat tolerant to 30 or so based on our data. So if you have a plant that gets hit, then it will usually abort the full set of flowers. So you lose the entire yield. There's also evidence suggesting that it will have more damage to its leaves. So getting that timing right, having flowering during a cool enough period, but warm enough is more critical, I think, than we had to deal with in the past if you want to actually maintain that yield. And this is an example from one of those regions outside of Montpellier. And then certainly we haven't been talking about it as much, but another one of the big extremes we're dealing with in Canadian regions, as well as they are dealing with in Western US regions, is smoke. And all the evidence suggests that the worst time to have smoke hit your vineyard is during veraison. That's when the berries are maximally taking up surrounding compounds. And so you'll usually get sort of the highest level of smoke taint in your berries if you have them hit around veraison. So lots of research and discussion of what do we do about this? Do we try to find varieties that ripen super early and deal with sort of the lower quality we might get out of them, but maybe they ripen before the fires? Or do we try to hope the fires are mid-season and have varieties that ripen later and aren't going to be undergoing veraison by the time the fires hit in July or August? Big, massive question and problem that I think we need more research on. And then certainly there's lots of evidence. Greg showed the same paper. I think it highlights in some ways how little data we have that we need. This is a wonderful paper coming out of the Côte d'Aron region, where that growing region has made a choice to invest in large scale research gardens. And they've been collecting a variety of data on their berries in this common garden in the Rhone for many years. So you can see here, I'm showing the evolution of alcohol in the decades. So the blue is the 1970s to the 1980s, the 1990s is in green, and then various versions of the 2000s, starting with 2003, which was the first major heat wave year in Europe. It was startling, and now heat waves are so regular, we don't even think of it, in the pinks and reds. And so this is just showing, like, we used to have this slow evolution of alcohol that would sort of start in August and really go through October, that slow ripening period that can produce very balanced grapes that are often more complex. And then it got shorter and faster in the 90s. And now it's really speeding up that entire process of development that seems critical to the quality of wine you can make from the berries. Again, Bécard et al., I think that paper is open access. You should be able to find it online. So how does variety diversity buffer wine growing regions? I'll walk very quickly through this because I think some of you have seen it before. This is work I did with a set of colleagues, especially Ignacio Morales Castilla, who's there on the left and is now based in Spain, and Inaki Garcia de Cortazar Atuari, who is based in France. And we basically asked the question of, if we tried to project future growing regions, and instead of doing what many projections have done for where we have wine grapes in the future, which is assume no change in growing regions, we assumed kind of a small change. We took some varieties and said, let's model them phenologically. And as they ripen too fast or have other delays or problems, we imagine that that variety will be switched for a later ripening variety in that particular region. So we first projected what would happen if growers don't change anything. So these are projected growing regions at 2 degrees Celsius, which you can see are far shifted towards the poles. It gets worse. Oh, sorry, let me start at 0. Here's the 0 point. So we projected where wine grapes would grow based just on their phenology. So this includes no actual data on where grapes are really grown, except for a little bit of the maturity modeling. And we projected quite accurately a lot of the places we are growing grapes. These are large grid cells, I will add, so they don't capture everywhere. But at 2 degrees, you see regions move dramatically north. So what we might expect with no change by mid-century. And at 4 degrees, sort of a potential scenario for end of century, we lose a lot of wine growing regions. But what we found was that if you actually allowed these varieties to change, the answers were totally different. So including variety diversity halved the projected losses I just showed you at 2 degrees and substantially reduced them as well at 4 degrees. So when you hear gloom and doom stories often of what will happen to projected wine growing with climate change, it often doesn't include any adaptation, the things we're here talking about today. And with just a little bit of adaptation in terms of changing varieties, which is a big change, but was limited in how many varieties we even had data on, we can totally transform those projections. I think the crop of wine grapes is a very climate resilient crop in many ways if we have the data and the consumers that are willing to adapt to that new crop, basically. We had a lot of simplifications in this project. I've hinted at it, but we had very few varieties, so it's limited in terms of how many varieties we could even imagine in this or include in this model. We also had a super simplified hardiness model here. So we said that regions could not grow a grape if we found 2 days below 20 degrees or 1 day below 30 degrees, I think in a 10-year period. We would rule out that region as just being too unsuitable at the lower extreme of temperatures for wine grapes. You can do much better than that. And I think for places like the Okanagan in Canada, this is something to investigate and work harder on. I showed you this model at the beginning, but I'm just showing the raw data now that went into it. So this is the bud hardiness data from the Research Center at Summerland. Winter hardiness levels measured on these buds, which are the growers share, and thanks to all of them for also the efforts to get these data together, is on the vertical axis, so -10 or -20, and then mean daily air temperature is on the horizontal. So stressing again here the idea that buds do not come ready to withstand hardiness in the fall. They have to be exposed to cold temperatures, and how cold those temperatures are will determine how hardy they get. There's no sort of hardiness below -10 in these data, not because that doesn't happen, but because it's hard to measure. So this is a fairly simple model, but we did include site level variation and we included variety level variation to try to pinpoint why we see so much variability in the data you see here. And you can use these models and translate them into frost risk in the Okanagan. So one thing we did here is looking at what we would project using previous climate data. So data for the last 30 years before 2024, so something like 1983 to 2024. Is that 30 years, 1993, or 30 years of data from the 90s to the 2000s, what would we have projected for freeze risk over the past historical period for a variety like Riesling, and then look at the percentage of years where we would have expected a freeze event, which is what's shown here. So yellow regions never freezing basically, and the darker blue regions having freeze events potentially every year. But I think getting higher quality models and thinking of translating them is a critical piece for people to think about as they want to decide what varieties to use. And I'll show you why here. This is using the same model, which again is based on the Ag Canada data from Summerlin. And all I've done is summarized over the previous 30 years of data we have, what percent of years does the model project we would have had a freeze event? And so if you start at the top and look at Syrah, and I'm just going to draw a purple line here for you. So if I think about the Similkameen region, whether it chooses to grow Syrah or Riesling, you can see Syrah is a little less hardy than Riesling. It has a higher percentage of days with freeze years, but it basically has a projected percentage of years that freeze that's like 15%, and Riesling might buy you down to 11 or 12%. Not necessarily a big difference to choose on the hardiness of the variety for the Similkameen, and to make that a critical component to think about. But if you're growing in Lillooet, so here I'm switching over to look at the green bars, which are from the Lillooet growing region. Well, here, if you grow Syrah, you're close to 50% of years potentially freezing. And if you chose instead for Riesling, focus on that middle black bar inside the green, you're closer to 27, 28%. So you almost have the amount of years that you would have a freeze event. So in places where hardiness is one of the most limiting factors for your particular site, choosing a variety that matches to your hardiness profile is really critical. Whereas I would say if you're growing in the Similkameen, you might need to be thinking harder about the heat tolerance and the ripening times. So there's all these myriad pieces you have to think about when you match the variety. As I said, it goes across the phenology, but it also matters what site are you in, what component matters the most to you to think about. And so this is a contrast of just two varieties, Riesling and Syrah. I picked them because they are both varieties grown in the region, so we have data to model them. They're also sort of extremely different in their hardiness. Extremely different being just a few degrees difference, honestly. You know, Vitis vinifera varieties tend to have very similar hardiness rankings. But Syrah is definitely less hardy than Riesling on average. So if you're trying to find a hardy vinifera variety, choosing Riesling is more important than choosing Syrah if you're in a region with a lot of cold events, I would argue. In terms of data I can give you and talk to you about for hardiness across varieties, especially thinking about Canada, it's supremely limited. We plant so few varieties, I would argue, in the Okanagan, and we focus on so few varieties that it limits what I can offer as help as a researcher. And that's not just an Okanagan problem, as Greg mentioned, it's a global problem. So these are data Greg has worked on coming out of Kim Anderson's group in Australia, and I have reformatted them here and done some synonymy issues on variety naming. But basically, the size of the dot is showing you how many varieties a region grows. So you can see lots of regions are growing 30 varieties, maybe 50 if they're lucky. Some regions in Europe are growing a lot more. The color of the variety, though, is the percentage of hectares for that region that includes, that are just the international varieties, as Jansen Robinson calls them. So what an international variety is, I put here on the right side: Cabernet, Chardonnay, Merlot, Pinot, Syrah, Riesling. You can probably guess them. And the darkness of the circle represents the percentage of hectares in a region growing those just 12 varieties. And so if you look at the West Coast of North America, most regions are growing 75 or more % of a very limited snapshot of varieties, as Greg also pointed out. And that is dramatically different than what you see if you zoom in on Europe. So on my estimates, there are, at least 1,000 wine grapes growing in Europe. and maybe 300 to 400 of them have been exported and are growing in any substantial amount outside of Europe. So we have really not tapped the diversity of this crop. And I know there's a lot of concerns about whether consumers would be interested in the diversity. I will say they're drinking all of the Spanish and Italian wines quite well. And we do certainly have some labeling issues about what we have trained people to get excited about, but there is a lot of diversity out there that we are not using. Okay, quickly, how are regions adapting? I've talked about this before. I think it's one of the most famous adaptation programs, partially because it's just one of the oldest. ViteAdapt, coming out of the Bordeaux region, was planted at least in the, I think it was planted in 2012, so planted over 10 to 15 years ago. They went out, they looked for what they thought were the 52 or so most probable varieties that they should consider as a region with warming. Lots of Spanish, a few Greek, some Italian varieties. They planted them all. And they're now at the stage where they're taking their top contenders, which I will say were not necessarily the varieties that they thought would be the top contenders, and planting them into vineyards. So cooperatively working together with those vineyards to get those varieties planted. And look at which ones are the best to promote for the region. So they're actively planting out varieties to figure which they should use, and then getting vineyards to be involved in that. I think vineyards in this region have a little bit more of a history of trying out varieties. This is even before that started. In 2013, this is one vineyard that made its own choice to plant 75 different varieties and track them and see what it thought would be good. So I do challenge growers to realize that places that are adapting are making big investments either in their personal vineyard or at a larger scale in trying out new varieties. You have to try them and figure out if they work for you. Similarly, Canopé, slightly new. This is a group coming out of Beaujolais, Burgundy, and Champagne that have got together. They are doing a suite of things. One of the things they're doing is building a massive greenhouse in Champagne to try out new varieties and test them. And I think if you look across what regions are doing, that is the consistent thing regions are doing. They are finding ways to plant new varieties, try them out, test them, and figure that out. How do you do that? You have to get better quality projection data and invest as a region or grower in figuring out what your future looks like. These are data from just one model that I pulled together for the Fraser Valley, Gulf Islands, Vancouver Island, so sort of the coastal regions of BC on top, and then the inland regions shown on the bottom. Maximum temperatures for June to August. These are average maximum daily temperatures across those months, and you can see it's projected to go up. So if you're growing in a coastal region by 2060, if it's mid-20s now, be prepared to be high 28 or so. And certainly the Okanagan region getting up to the 30s on average maximum temperatures. But if you want to decide what varieties you should plant as a region, you have to choose the wine style and the priorities of how you want to make wine and how you want to grow it. And I think that's a choice that has to be made as, you know, if you want to do it for your own vineyard, you have to have that answer ready. I want to be making Champagne style grapes, or I want to be making a robust red. And then certainly we all have to understand and cope with the uncertainty, especially as Greg stressed, for precipitation. And we're still not sure what happens with extremes. They're certainly going up. How fast and how is really cutting edge science that I think we don't have great answers for, unfortunately. And with that, I will thank everybody, many people who have helped on this, and stop sharing my screen, and thank the CGCN and Dr. Jones again.
Thank you very much, Lizzie. You mentioned at the beginning of your presentation, and I think there's just a few things I wanted to highlight in it, is that at least in the Okanagan Valley, you noted a downward trend of freeze events, which I'm sure if we have anyone from the Okanagan Valley joining us today, that's probably reassuring to hear. Doesn't mean they're going to go away, but definitely means that they should be on a downward trend. You were also mentioned some hazards, and one of the things, there's a couple things that we within our past cluster we started researching. We're also continuing this year. So smoke taint at Verizon. How do we mitigate that impact? You said there needs to be a bit more into that. Definitely need to look more into that. Another thing I wanted to highlight is that in order to adapt, there needs to be more investment into the research, into the innovation. So that's definitely something that not just CGCN wants to advocate for, but I'm sure all of the provincial growing associations advocate for as well, and especially out there in BC. And choose your varieties based on the industry priorities or what your personal priorities are, but just be prepared to cope with whatever the uncertainties are going to be. All right, so that concludes both of our presentations from Lizzie and Greg, and I want to open the floor to any questions that our audience members may have. But actually, while you were presenting, a few questions came in, and if you didn't catch it, I just want to bring them forward right now to maybe discuss in a bit more detail. I see, Greg, you kind of addressed them in the chat, but I'll also bring attention to them here now. So first one, given the current political trend towards climate change denial, what can we do as an industry to mitigate or slow down this trend? You touched on that we should be our own stewards of our lands to develop frameworks that limit our impacts. Did you want to add anything else to your statement there, Greg, or maybe Lizzie as well?
Well, and you know, I think it was Hans. Yes, Hans, thanks for the question. And you know, this is really unfortunate. And I can even go back to when I first started, working in the climate science arena. There was so much not in my backyard. I mean, it was extreme, and it happened whether I was in Bordeaux, Napa, Barossa. It didn't matter. And so we've gotten better, and I don't know whether that's just because there's more knowledge out there. We've had more experience. We've actually been more impacted, so maybe people are more in tune to that. But the political environment is so damn self-serving. Pardon my expression. I just really think it's unfortunate because it'll always end up being that way. So I guess what I was trying to say there is that we need to kind of let that, do its own thing and be our own good stewards and do the best thing we can. Because the political environment doesn't agree with it, it doesn't mean you shouldn't do something.
Yeah, absolutely agree with that. And one of the highlights of our research cluster was to frame projects around climate change. So that is definitely something that is a reoccurring theme for research, at least in Canada. A couple other questions that I've asked, actually one of them that I want to address here, that you did address already, Greg. Are there also longer trend cycles than the decadal oscillation that we are aware of and might have some impact on current trends? You mentioned that there are longer term solar cycles that are playing a role, but during the last 50 years, very rapidly warming, so solar cycles have been less influential driving trends.
Yeah, and all I was getting at there, I mean, you could go to Berkeley Earth and find their framework behind this, and it's really the idea of attribution. Where are we attributing the issue of a warming climate? And you can see the framework behind volcanic eruptions, especially the most recent ones. You can also see the framework behind solar cycles. But the largest contributor is just simply greenhouse gases and human activities.
Yeah.
I mean, I think I've always said is that you can't put 8 to 9 billion people on this planet, change the surface characteristics, which in turn change the energy characteristics of the surface, change the atmosphere, which in turn changes the energy characteristics of the atmosphere. You can't do all that and not have some broader framework going on. So it's the dominant driver of climate change is human activity. That's pretty clear. It's just that what I was getting at in some of the shorter term cycles, when we have, science can find, frameworks behind, something like the Pacific Decadal Oscillation or the North Atlantic Oscillation, where we can better understand what those look like. So we can say, if we're in this situation, we can expect conditions to be like this. But given the warming that we're seeing, those relationships in the past, they're going to be different in the future.
Definitely.
And I was
Lizzie, did you want to add something?
I think one thing I sometimes miss as a scientist, and I miss communicating, because as a researcher, I'm You know, I never am 100% certain of almost anything. And so I stress the uncertainty. We're less certain about our drought forecasts. We're less certain about this versus our temperature forecast. We can't get the extremes as well because they're rare events, so they're harder to estimate. But I think what often gets lost in that is that when you're dealing with uncertainty, the greatest uncertainty we're all dealing with is human action. So we're all now trying to forecast a future in which we don't actually know the forcing scenario of greenhouse gases. And that is just a massive waste of how we adapt and mitigate. If we had a comprehensive agreement and knew when the climate would start to stabilize, we'd all end up with better wine growing regions and better wine grapes and less sea level rise. And I think that I just want to stress to people that when you hear about all this uncertainty, we don't know what's going to happen. We actually have been highly accurate on our temperature forecasts for the last 30 years. We've understood the science behind this for over 150 years. We focus on the uncertainty as researchers, but the greatest uncertainty we have in what's going to happen to the climate system, I would argue, is the choices we make about anthropogenic forcing, the human cause forcing that we're all contributing to is where we could really narrow down that uncertainty if we had a climate change agreement that we were all on top of. And then growers and researchers could really focus their efforts much better on how do we adapt to what we expect now that we can really limit that outcome into a range of greenhouse gas emissions versus this huge band of like, when do we start limiting greenhouse gases? Is it next year or is it in 30 years?
Mm-hmm.
And just to add to that, I think Lizzie's spot on. But one of the things that holds true for me, only just because I'm older and I've seen some of this, is the initial models that I was using within every climate framework I was working on in the early 90s had very crude understandings of everything. How snow and ice interacted with the atmosphere, how the land surface interacted. It had very crude estimates of carbon dioxide in the atmosphere. And they were also running at time stamps of a month to 3 months. And they were running on spatial frameworks of 5 degrees of latitude. And yet the results from that, fast forward to 2020, were nearly spot on. They were a little off here and there, but that tells me that we need to be more certain about what we're seeing in the models going forward, because they are so much better than they were 30 years ago.
Yeah, and I think it's true that you're saying a lot of your models are pretty accurate in predicting, but it's more difficult to predict what humans are going to do. I have a question from one of our audience members. We were talking more about adaptation, but what are some mitigation strategies that can be suggested for reducing cold damage, if you have any suggestions?
You know, that's a real difficult one. I don't operate in the cold environment as cold as was experienced anywhere in Canada. I'm 30 vintages in my vineyard, and we've only had one true frost. And so I do know that even having one frost in 30 years is a problem, because we were so unprepared for it, because we had no cultural experience with the physical event. And we just, I mean, like we thought we were ready, but we weren't. And so I think being aware and being timely, no matter if the frequency is low, you need to think about how do you respond, or how can you create something that's more suitable. I've been to China a couple of times, and I can tell you they do some pretty extensive things in China to limit cold damage. And I'm not saying that needs to be done, but there's some adaptive processes out there that work. Some of them are more expensive than others, but I think we all need to consider whatever options are possible. I'll go to an adaptation that doesn't have to do necessarily with cold responses, but a warming climate. Our move from dozens of different types of trellis systems in Europe to a VSP trellis, I think, was in response to a 1960s, 70s, 80s climate. So we tightened up our canopy to these real tight, low vegetative frameworks by which we're trying to make the vine do as much work as it possibly can in a cooler environment. And now we're in a warmer environment. Those VSPs don't have enough leaf cover. They don't have enough ability to shade fruit. We're in my vineyard, we're doing shade cloth trials because we've got way too much sunburn. And so I'm trying to follow some frameworks what other people have been doing so that I can protect. But that's an adaptation. Looking at my trellis structure and looking at how can I maximize it for a warmer environment, higher heat stress and higher solar stress. So there's just a lot of things like that that we just need to be smart about.
Yeah, I would echo that, cold hardiness, there aren't as many options as perhaps dealing with certain heat tolerances, but all of these things have to do with knowing your varieties, where your variety is at in terms of what stress it can withstand for a high temperature or a low temperature. So I think having the data, if you're in the Okanagan, and I believe they have similar data in Ontario, to know the cold hardiness of your vines and making sure that is something that as a growing unit you invest in is important, so that you can say, for my vineyard, I know that my vines usually get this cold hardy is really helpful. So if it's -23 and you have your temperature record and your vineyard gets to -24, -25, depending on the shape of your vineyard, that narrow a margin of 2 degrees, maybe a wind machine would help. But if you're growing somewhere where you get -28 regularly and you've planted a -23-degree vine and that's its maximum hardiness, yeah, you're in the range of like, am I going to choose to bend over my vines and bury them every year? So you really have to be aware of the varieties you're growing, what their tolerances are, how those tolerances actually function in your region. Because again, if you're in Ontario, you're not going to get the same cold tolerance year to year that you will get in BC, which is colder. And then what is the historical regime of my vineyard and what is the future regime? And figure out, how far off am I? What level of safety margin do I have to come up with? And the bigger it is, the harder that adaptation strategy will be, which I think is why Greg and I so much suggest really carefully matching that variety to your climate so that you have so little of that to deal with ideally.
Absolutely.
Well,
Some
and I
common
think,
techniques.
Lizzie,
Oh, go ahead.
I think, Lizzie, what you're also saying is something I think is really important. Every single individual needs to know what their own risk tolerance is. It could be, I'm willing to have a 1 in 30 year kind of impact to my business that I'll have to deal with. Some people might be 1 in 50. Some people might be 2 in 10. You need to know what that risk tolerance is and play to that game. And you can do it with varieties. I mean, if somebody were to come to me in my region and ask me about planting Cabernet Sauvignon over there, I would say you're not going to ripen it 6 years out of 10. So why would you do it? And so you really have to think about those kind of frameworks when you're dealing with whatever you're planting. And I mean, it's your own personal risk tolerance versus the physical tolerance of the plant system that you're working with.
Absolutely. And then it comes down to also the level that you're willing to invest in your vineyard. If you need to bury your vines every year, that there's a lot of labor involved in that. Are you willing to take that on? So we're almost at the bottom of the hour, so I'm going to wrap up our presentations here today. I just want to thank our two guests, Greg and Lizzie. Thank you for taking the time to be here with us, share your knowledge with the Canadian grape and wine industry. I hope the information that you've provided to us and the growers have gained from this session will be able to use that in the growing season coming up this year. And there we go. Thank you very much for joining us. We hope to announce more webinars, and we actually have more webinars in the works in 2025. So in the coming weeks, check your emails, stay tuned to our social media channels or through our website if you want to be updated on some future content. This webinar has been recorded. It will be posted to our website, CGCN's website, or to our YouTube if you ever want to revisit it or send it to someone who was unable to attend, or just revisit as you need. But lastly, before you exit or when you exit the webinar, you'll be asked to complete a brief survey where you can share your thoughts on today's session. And we would really appreciate it if you could take a couple minutes to fill this out. It helps us to improve our sessions moving forward. And thank you once again, Greg and Lizzie, for taking the time today, and to everyone here for attending. I hope you enjoy the rest of your day.